Hello everybody, it's about 4:15 on Friday, January 20th, 2012, and this is a educational video on freezing rain, sleet, and snow, and how to forecast it. I'm making this video because this evening we're going to get some freezing rain, and we're already getting some freezing drizzle outside my house right now. Or I checked my windshield, it's definitely freezing. Uh, but the main thing, the main storm system that's going to bring this precipitation is this one right here, moving out of Kansas into Missouri, Illinois, and Iowa. Sorry, we got some heavy snow reporting in Chicago. Precipitation will continue to develop through the afternoon and evening hours and spread across the area, bringing freezing rain because the temperatures are in the 20s. Road surfaces are below freezing, and this will continue through the evening hours, bringing a nice coating of ice to the surfaces, especially untreated surfaces and bridges and overpasses and roadways that are much less used, like neighborhoods. So if you're out and about this evening, be very careful. Drive slow. Do not drive like an idiot because you may hit a patch of ice, black ice, and lose control of your car, slide off the road, and bam, that's it. I don't need to say anything more about that. But like I said, the main purpose of this video is to educate you on why we're getting freezing rain instead of sleet or snow. Some of you may have seen a graph like this. This is an atmospheric sounding. We use this to predict what kind of precipitation we are going to get. These are plotted using weather balloons, sensors that are on weather balloons. You've all seen weather balloons being launched into the air, either in a textbook or on TV or anything, you know. At the very end of these weather balloons are sensors. These sensors measure temperature, pressure, wind speed, and the dew point, and they're plotted on this. This is called an atmospheric sounding, or a profiler, an atmospheric profiler. Now, to me, just looking at this graph, I know exactly what we're going to get. We're going to get freezing rain. I know this. I can look at this for a split second, and I know this is a freezing rain chart. Why is that? Okay, first off, let's explain the chart real fast. These bars over here are the wind speeds. I mean, there's a wind speeds and direction. Wind's coming out of the west mostly with the trough, and you can see this with the graphic right here. National analysis. This is 500 millibars. Wind's coming out of the west. Plain and simple, easy. Okay. This bottom row right here is the temperature from negative 30 degrees Celsius to 40 degrees Celsius. This left-hand side here is your pressure or your height, your altitude. Starting at 1,000, this is actually the real surface, 1,013 pascals, hectopascals, or millibars. But in St. Louis, it's around 1,000 millibars. We are above sea level, so it's 1,000 millibars, St. Louis. And it goes up. This is 850, 700. This is about between 4,000 and 5,000 feet, about 4,500 or so. This is 700 millibars, or about 10,000 feet or so estimated. These are all rough estimates. It changes every single minute, every single day. It changes. But rough estimate of 9,500 to 10,000 feet. And goes up from there. This red line here is the temperature line. This green line here is the dew point line. And you put this all together, and you get an atmospheric sounding. Now, why is this sounding showing freezing rain to me, the trained eye? As you all know, or most of you know, precipitation starts as snowfall, way up in the atmosphere, and it falls to the surface, and it either falls as rain, sleet, or snow when it hits the surface. Occasionally you'll get grapple, but I'm not going to explain that. Okay, so why are we getting freezing rain? We're getting freezing rain because as you follow this temperature line down, first off, when the temperature and the dew point meet, that usually means clouds and rainfall, and it goes all the way down. When it's like this, you're getting precipitation to the surface. So this temperature and dew point meet around just below 700 millibars, about 710, 720 millibars or so. When this meets, you're going to have precipitation that forms in this region. Because it forms above freezing, it's going to start as snowfall. So we have snow around this area. Now, this line right here, I forgot to tell you. This is the 0 degree Celsius line, or the 32 degree Fahrenheit line. This is your freezing line. Okay, so it starts to snow above freezing. Now, when this as it goes down, it goes down the atmosphere towards the surface. It hits this line. It hits this freezing line. And when it passes up the freezing line, it melts into rain. Okay, you following me? Because it's on the warm side. This is the warm side. This is temperatures above freezing. On this side, it's temperatures below freezing. It's melting through this layer. So once the snowfall melts, it melts into a liquid raindrop. Okay? And as it continues to fall towards the surface, it continues to be above freezing. The raindrop continues to warm until it gets to about the atmospheric temperature, this maximum temperature of about, I say from this about 38 degrees Fahrenheit or so. So this raindrop through this layer is about 38 degrees. Now, as it continues to fall towards the surface, it hits this line again. It hits this freezing line again. And once it gets to the left of the freezing line, the raindrop starts to cool. It starts to refreeze. But because it's so close to the surface, it doesn't have time to refreeze into a sleet pellet yet. Into sleet. It just gets cooler, but because it's below freezing at the surface, and because the surfaces are below freezing, once that raindrop hits the surface, and because the temperatures are outside of 28 degrees, it freezes. This liquid water starts to freeze on the surface, and that is what we call freezing rain. Because this warm layer, is so deep, and this cold layer at the surface is so shallow, the raindrop that started as snow and works its way to the surface, it doesn't have time to freeze again into a sleet pellet. And that is why we're going to have freezing rain today instead of sleet. And well, snowfall would be if this entire line was cold. If the entire line was cold, it'd be all snowfall. And I'll show that here in a second. But that is why we're getting freezing rain. It's because this layer is warm and it's such a large layer that the raindrop that the melted snowflake, aka turned into a raindrop, it warms up, and yeah, once it gets down closer to the surface, it slowly cools down, but it doesn't have time to cool down to a sleet pellet yet. The layer is too shallow for it to cool all the way to sleet to refreeze. Now, let's go back to an old event. This is a classic sleet sounding. This is sleet. I can tell you right now, just by looking at this is sleet. First off, this is the February 1st epic blizzard through central Missouri, western Missouri, and the epic sleet storm that hit St. Louis. So it's supposed to be 20 inches of snow. This is a sounding out of Springfield, Missouri. Now, why did I pick this sounding? I probably should say as well, this is a model sounding. This is the Wrap It Up They Cycle model for St. Louis. But this is an actual sounding coming out of Springfield, Missouri. And why do I know that this is a sleet sounding? Because here's the 0 degrees Celsius line. Once again, your red is your temperature, green is your dew point. This is also a much stronger system, so the layer is much deeper. There's a lot more moisture in the atmosphere, so you've got a lot more heavy precipitation. But you can see it from this layer right here. Is this as big as this layer? No, it's not. The temperature gets just above freezing for only a couple thousand feet, not this large layer of above freezing temperatures. This is a very shallow warm layer, a very small warm layer. And because this layer is so small, the snowflake melts, but it does not get much above freezing. It may hit 32 and a half, 33 degrees. But once it gets back into this layer is much deeper, and it's colder as well. So the raindrop has time to refreeze again and fall to the surface as sleet. This is a classic sleet sounding. This is your classic freezing rain sounding. See the difference? This is why we got sleet instead of snow, because this layer right here did not cool. It stayed that temperature throughout the entire time. And that is why we got sleet instead of 20 inches of snow like Columbia. Now, why was it so hard to forecast? It's so hard to forecast because there's not a sounding in St. Louis. There's not an official weather balloon launch in St. Louis. These are the sites. You get these red dots around the country are the sites of where weather balloons are launched. As you can see, there's a gap, a pretty large gap between St. Louis. Our sites we use come from Springfield, Missouri, mostly Springfield, Missouri, Topeka, Kansas, and Springfield, Illinois. But in this area, right in here, this includes St. Louis, it is very, very difficult to forecast for winter precipitation. Very difficult. You have no idea how many times I've been frustrated by forecasting winter weather because of this large gap. You get this gap in the data. The only thing you use is models. Well, models are not perfect. There's not a perfect sounding in a model. This is not perfect, I bet you. There's probably a couple degree difference in this layer. But that is why we got 20 inch. That's why Columbia got 20 inches of snow. We only got 3 inches of sleet. Because this layer right here, that is it. That is the one reason, and the main reason, the only reason why we got sleet instead of snow. So that is. Well, I guess I'll show a quick snowfall graphic. This is what a snowfall. Let's just try to find a better one. This is a good one right here. Any other ones? Yep, that one's not there. But as you can see, it's a snow graphic, snow sounding. Temperature, the entire layer is below freezing. When that happens, you're going to get snow. Simple, plain. Look at it, snow. Boom, there you go. So that's the main reason why. So that's the main difference between sleet, a sleet sounding, and a freezing rain sounding. Those are the main differences, and that is why we're going to get freezing rain today instead of sleet or snow, because this layer is a very warm layer, it's a very large layer, and you have a very shallow layer at the surface. Cool there. So that is why. I hope that helps explain things a little bit on freezing rain, sleet, and snow, and why it's very hard to forecast for these events in St. Louis and throughout the entire country as well. But now you see what we look at when we try to forecast on precipitation type. Also, these things are very, very important for a severe weather season. Very, very important for a severe weather season. It's a completely different thing. I'll explain that later. Explain that later someday. So I hope you guys have a good day. Be careful, and I'll talk to you later.